Hi guys and welcome to this video. Kalina here, and today I'm going to be taking you through the solution to this Leaving Cert higher level question. This is from paper 1 and it's one of the longer questions worth 50 marks in total. This one is based on calculus and mostly integration, so let's get right into it. In this question, we're told that there's a Ferris wheel which has a diameter of 120 meters. We're told that it completes 10 full rotations in 1 hour. It shows us that the diagram is of the Ferris wheel before it starts to turn, and at this stage the point A, which was shown here, is 12 meters off ground level. We're told that the height h of the point A after the wheel has been turning for t minutes is given by the following formula, and that is h of t, so the height of the point A, is equal to 72 minus 60 cos pi over 3 t. And again, t stands for the minutes after it starts to turn. So h is in meters, t is a real number, and pi over 3t is in radians. When we're told that something is in radians at the start of the question, the first thing that I would do is put my calculator into radian mode if it's already in degree mode. And I'm going to show you quickly how to do that now. So as you can see, my calculator is already in radian mode because you can see the small r up on top just here. If you have a small d up on top here, you need to change it to that small r. And how are you going to do that? You are going to press shift. You're going to press the button that says mode and setup in yellow. And then you can see here, number 3 is degrees and number 4 is radian mode. So press 4 for radian mode and your calculator is ready to go for the question. Now in question A, we're asked to complete the table below and that the value of h1 is given. All we need to do in this question is fill in the values of t into the ht equation. So I'm just going to start off with t is equal to 0 here. So we can go 72 minus 60 cos pi over 3 t is 0 and put this into our calculator. So h of t is 12 when t is 0. And that makes sense because when no time has passed, we know that the point A is 12 meters off the ground. So I'm just going to write in here 12. Now we can keep just going back and changing the value of t. One thing to note, if you're struggling to find pi, if you have a Casio calculator, the same as mine on the screen, what you're going to do is press the shift button and then press the button in the middle of the bottom row. And you can see the pi up there in yellow. So press shift and then press that button down in the middle of the bottom row. So we can go back along here and change that 0 to 2 because number 1 is done for us. And that's 102 meters. And just keep going until you have all the values filled out. I have all my values filled out now. So that's all you need to do for that question. And one thing just to note, and this is going to come in handy later in the question, but just to see from a logical point of view that A starts 12 meters above the ground. Now, when does it come back down to 12 meters? And we can see that it's again at 12 meters after 6 minutes have passed. So it does a full rotation in 6 minutes. So that'll be important to note as we go forward in the question. Question B here follows on from question A. It asks us to draw the graph of y is equal to h of t from 0 minutes to 8 minutes. So that's basically just drawing the graph of the box that we have just filled out. So let's start when 0 minutes have passed. How many meters above the ground is A? and it was 12 meters. So just use your table, go back to your table for this. When 1 minute had passed, the point A was 42 meters above the ground. When 2 minutes had passed, it was 102 meters above the ground. When 3 minutes had passed, it was 132 meters above the ground. After 4 minutes, it was back down to 102 meters above the ground. After 5 minutes, again, it was 42 meters above the ground. When 6 minutes had passed, it was 12 meters above the ground again, back to where it started. And then in 7 minutes had passed, it started increasing again, back up to 42 meters above the ground. And at 8 minutes, it was 102 meters above the ground again. Now, once you have all your points plotted, what you're going to want to do is join the dots to make a nice shaped graph. Of course, your graph doesn't have to be absolute perfection, but when you're drawing your graphs, I would recommend that you just at least make sure that all the correctly plotted points are in the line that's joining them. Drawing graphs are definitely something that I'd recommend practicing when you're studying maths for the Leaving Cert. It's something that's often left out because it can be deemed quite manageable in relation to other aspects of the Leaving Cert maths course, but they do often contain a lot of points. Like for this question here, you're going to get 15 marks for filling out the box and doing the graph, which is a hefty amount of marks, so you wouldn't want to miss out on those by just not having practiced your graphing skills. Now let's move on to question C. Question C asks us to find the period and the range of h of t. Now, what does this mean? The period basically means how many minutes it takes to come full circle. So we know that that is 6 minutes, and we can see from our graph here that it starts at 12 meters and it comes back to 12 meters at 6 minutes. So that's one period done here after 6 minutes. So the period is 6. Now the range is the lowest and the highest point on the graph. So let's have a look here. We know that the lowest point is 12 because A starts at 12 meters above the ground. What's the highest point? And the highest point here is 132. So the range is 12, 132. And for this question, you're going to get 5 marks. On to question D. We're told that during a 50-minute period, what is the greatest number of minutes for which the point A could be higher than 42 meters? So in one period, there's 6 minutes. So how many periods are in 50 minutes? 50 divided by 6 is 8 periods plus 2 minutes. Because 8 periods is 48 minutes. So then we're going to add on those 2 minutes. So in one period, how many minutes is point A above 42 meters? Now let's go back to the graph to have a look at this. So in one period here, from 12 to back down to 12 here at 6 minutes, for how long is it above 42 meters? So from here to here, goes from 1 minute to 5 minutes, so it spends 4 minutes above 42 meters. So in one period, 4 mins above 42 meters. So how many minutes would it spend above 42 meters in 8 periods? So 8 multiplied by 4 is 32 mins in 8 periods. So it's 32 mins above 42 in 48 minutes, okay, because that's 8 periods. But we need to remember that it asks us what is the greatest number of minutes. And the greatest number of minutes means that we can't forget about these 2 minutes here, that it also could be above 42 meters. So we need to add those two on. So plus 2 minutes. So we'll say the greatest, 34 mins above 42 meters in 50 minutes. And that is your answer here, and that will give you 10 marks. Now let's get started with question E. Question E is, in my opinion, the most difficult part of this question, but I'm really going to break it down and bring you along with me. We're asked to solve the following equation to find the second time, so the second value of t, that the point A is at a height of 110 meters after it starts turning. So this is the equation that we're asked to use. And it makes sense because here we have our h of t, so the height of A, okay? So we're saying that that is equal to 110 meters. So there's two methods of using this. The first method is using your unit circle. If you are really confident using your unit circle, this is definitely a method that I would recommend you to use. There's also a more visual and, in my opinion, a more logical method. So I'm going to start with that and then I'm going to briefly cover the unit circle method as well. So here is our Ferris wheel. This line here is going to be 110 meters. So the first time it hits 110 meters, so it starts here at point A, the first time it hits 110 meters is going to be there, and that is going to be t. But it asks us for the second value of t. So our second value of t is going to be here. So this is t1 and this is t2. We're looking for t2. So let's find t1 first. So we have 72 minus 60 cos pi over 3t1. I'm going to write it as t1 just to help myself remember, is equal to 110. So minus 60 cos pi over 3 t1 is equal to 110 minus 72, and that is 38. So cos of pi over 3 t1 is equal to minus 38 divided by 60. So I'm bringing the minus 60 over here and dividing it under 38. Pi over 3 t1 is now equal to the cos inverse of minus 38 over 60. So now let's use our calculator to find out that pi over 3 t1 is equal to, so put in cos inverse, so press shift and then cos, minus 38 divided by 60. And that gives you 2.25664. So T1 is equal to 2.25664 divided by pi over 3. So I'm going to bring this under here. And that is 2.1549. Now, what does this mean for us? This means that the first time that the Ferris wheel is at 110 meters, or this point A is at 110 meters, T1 is 2.15 meters, correct to 2 decimal places. But that's not what we're looking for. We're looking for the second time that it's at 110 meters. But how are we going to find that? We know that a full rotation of the Ferris wheel all the way around here is going to take 6 minutes. We also know that, and I'm going to use a pink pen here, this distance here is the exact same as this distance here. So if we take 6 minutes, take away 2.5 minutes, which it's also going to take to get from T1, or T2, my apologies, back down to the original point of A, then that is going to find us the T2 value. Okay, so let's get our 6 minutes. Take 2.15 minutes, and that will give us 3.85 minutes. And that is the time that it's going to take for A to reach 110 meters for the second time. So that is the answer to this question, and for this question you're going to get 10 marks. Now, as I said, if you're more comfortable using the unit circle method, then by all means use this as well. I'm just going to briefly run over a few steps with the unit circle method. So if you have your unit circle here, you have your 4 quadrants, you have your all quadrant or your universal quadrant, sine quadrant, tan quadrant, and cos quadrant. So you have 0, pi, 2 pi here. So you're going to want to find your reference angle. We know that when you get to this stage here, you have that pi over 3, my apologies, t is equal to, cos of pi over 3t is equal to minus 38 over 60. You know that the cos is going to be negative, so it can't be in the cos quadrant, because if it was positive then it could be, but if it's negative it can't be in the cos quadrant. The same with the all quadrant, so it has to either be in the sine quadrant or the tan quadrant. So find your reference angle by changing this into a positive number here. Find theta, and theta is basically just t. And then find it in the sine quadrant, so that is going to be pi minus theta. And in the tan quadrant, it will be pi plus theta, to find the first and the second time that t, or theta in this case, is going to be 110 meters. And you will end up with the same answer of 3.85 minutes. Now let's move on to question F. This is the final question in this long 50-mark question, and it is an average value question. It asks us to use integration to find the average height of the point A over the first 8 minutes that the wheel is turning, and to give our answer correct to 1 decimal place. And it tells us to remember that h of t is 72 minus 60 cos pi over 3t. So this is an average value question. So we're going to want to get 1 over b minus a of b a ht. So let's fill this out. We know that b is going to be 8 and a is going to be 0 because it's over the first 8 minutes. So it's from 0 minutes to 8 minutes. So we're going to have 1 over 8 minus 0, which is just 1 over 8, from 8 to 0, 72 minus 60 cos pi over 3t. And we're going to integrate this here. So we still have 1 over 8 as 8 goes to 0. 72 integrated, it's going to become 72t. Now the next part is a small bit more difficult to integrate. You can use your log tables for this question if you like. You can see here in this page of the log tables, which is page 26, that the integral of cos of x is sine of x. So we already have 72t. You are then going to go minus 60 sine of pi over 3t. And then what we have to do is we have to divide by the coefficient of t. So divide by pi over 3. Another way to write this is, we'll keep going with 1 over 8, from 8 to 0, 72t minus 60, oh my apologies. Instead of dividing by pi over 3, I'm going to flip it around, so put the 3 on top here, and oh my apologies, and become a multiple there. So I'll just show you. So it's going to become 3 multiplied by 60 sine pi over 3t, and keep the pi on the bottom. So let's multiply this out a small bit before we start filling it in. So we have 1 over 8 again, from 8 to 0, 72t minus 3 by 60 is 180, sine pi over 3t over pi. Okay, so now let's start filling this out. So we're going to have 1 over 8. Let's fill out for t is 8. So 72 multiplied by 8 minus 180 sine pi over 3 by 8 divided by pi. And then we're going to take away when we fill in for 0. So take away 72 by 0, which is just going to be 0, minus 180 sine of 0, because it's pi over 3 multiplied by t when t is 0. So it's just the sine of 0 all over pi. Now let's pop this into the calculator and see what we end up with. So we have 1/8 on the outside. Now 72, I'm going to put in another bracket there. So 72 multiplied by 8 minus 180 sine pi over 3 multiplied by 8 divided by pi and then we're going to take away 72 multiplied by 0 minus 180 sine of 0 divided by pi. And that gives us an answer of 65.797 meters. So that is the average value of the point A over the first 8 minutes. We must just notice that it asks us to give our answer correct to one decimal place. So let me just brush up on that. So 65.795 meters is going to be 65.8 meters. And that is our final answer. And this question is worth 10 marks. Okay guys, so that is all for this question. I hope you found the solution video helpful and that it might have cleared up any issues that you had yourself when going through the question. Thank you very much for watching and I'll see you all in the next video.